Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today I would like to continue our lecture. We will analyze how to analyze the indeterminate truss using flexibility method. Before we start our lecture, we should understand about the learning outcome of this topic. At the end of this topic, students should be able to, number one, identify the DOI, which is DOI later become our redundant. Then after you remove that redundant, you must have the ability to sketch the primary structure system and redundant structure system, which is actual structure equal to primary structure system plus redundant structure system. That principle we call principle of superposition for truss structure. Then after you have sketched your primary structure plus your redundant structure system, next we will determine the displacement for each system by using virtual work method. Each system here will refer to primary structure system and redundant structure system. If you have one DOI, you have one redundant structure system. If you have two DOI, you have two redundant structure system. If you have three DOI, you have three redundant structure system. Then you will form the compatibility equation and solve for the redundant force, internal member forces, as well as deformation for statically indeterminate truss structure. The term compatibility equation here, this is the equation about displacement. Okay, this is the equation about displacement. Displacement for actual structure equal to displacement for primary structure plus displacement for redundant structure system. This is learning outcome for subtopic how to analyze indeterminate truss using flexibility method. The principle and all the equation for this subchapter similar what we did for how to analyze the beam structure and frame structure. So due to that, straight away we go for example. In the note, example number 7, let we consider one truss ABCD loaded with UDL 10 kN per meter on member BC. Then this question asks you to calculate member forces of the truss if there is a horizontal movement of support D by 800 over EA. At D, they have support movement in X direction. Sorry, in X direction to the right. Okay, 800 over EA. All members have constant stiffness EA. Of course, before you analyze this structure, you need to convert this UDL become point load. 10 multiplied by 10, 100 divided by 2. You apply 50 at B and 50 at C. Okay, as we discussed for the beam and frame, the first step we must calculate the DOI. For truss, to determine the DOI, M plus R minus 2J. So M represent the member 1, 2, 3, 4, 5. R represent for the reaction. You have a pin support at A and pin support at D. So two reaction at A, two reaction at B. So this is 4 minus 2J. J represent the join. You have join at A, join at B, join at C, and join at D. So 2 multiplied by 4. So 9 minus 8 equal to 1. So this is indeterminate truss with 1 DOI. So this DOI, you must classify whether this DOI external or internally. In this example, this DOI 1, this is externally. They have a 4 reaction at A and B, minus 3 equal to 1. So this is 1 DOI externally. When you have an external DOI, so your redundant force must from the reaction whether at A or at B. It means your redundant force equal to 1. Your redundant force equal to 1, you must remove one reaction. Okay, you must remove one reaction because this is external. Okay, so step number 2, you must sketch the primary structure and redundant structure. Okay, to sketch this structure, you must remove your redundant force, and your redundant force for this solution, you choose dx. Okay, even though that's not stated here, please you write somewhere. We have choose our redundant force dx. Okay, that's why you must remove dx to form your primary structure and redundant structure. That's why for the actual structure at D, originally they have a pin support. Now after you remove dx, that's why at D here they have a roller support. Okay, because your primary and redundant must statically determinate structure, even though your actual structure statically indeterminate structure, but your primary structure and redundant structure must statically determinate. By you remove the redundant force. When your DOI equal to 1, your redundant force equal to 1. Now because of DOI externally, so you remove the reaction. In this case, we remove the dx. Okay. So when you remove the dx, your actual structure equal to primary structure plus redundant number 1. Because now you have 1 DOI only, that's why redundant structure you have 1 only. Okay. The principle of superposition, actual structure equal to primary structure plus redundant number 1. Okay. For primary structure, you remove effect dx. That's why at D they have a roller here. All the real load, actual load, you just apply on primary structure. That's why they have a 50 kN here and 50 kN here. For redundant structure, they have same structure with the primary but different in terms of loading. Okay. For actual load, we just apply on primary structure, and for redundant structure, you just apply 1 unit load. Where you want to apply 1 unit load depend to your redundant force. You select just now your redundant force dx. That's why you remove dx. So when you remove dx in your redundant structure, you must apply 1 unit load at D in x direction. Whether your load to the right or to the left, that doesn't matter. Okay, but your load must at D in x. Why at D in x? Because your redundant force, you choose dx. You remove dx effect to form your primary and redundant. Now you have calculated your DOI and you have sketched your actual structure equal to primary structure plus redundant structure. Next, you need to calculate the internal forces. You need to calculate the internal forces for primary and redundant. Okay, you need to calculate the primary and redundant in terms of internal forces using this N0 means this is the internal forces for primary structure. N1, this is the internal forces for redundant number 1. This is length of the member, and this is the member AB, AC, AB, BC, and CD. How to calculate this? Internal forces for primary and internal forces for N1. You can use the method you have learned during your previous semester under CS 424. You have learned how to calculate internal forces. In this example, the easiest way to determine internal forces, the best is better you use joint method. In this case, we use the simplified joint method, or normally student term as a easy method. Okay, actually this is joint method, or we can call simplified joint method. So after you have determined this internal forces for primary structure, internal forces for redundant structure, then you can calculate displacement. Okay, you can calculate the displacement for primary structure. This is displacement due to 1 unit load for redundant structure. As mentioned from the previous, when I derive the equation for compatibility equation, delta 10 mean displacement number 1 mean displacement at D in X. Displacement at D in X when we refer to primary structure. This we calculate displacement at D in X when we refer to when we refer to redundant number 1. Primary and redundant number 1, we refer to this structure. We calculate the displacement dx due to this type of loading. So you get this value and this value. So after you have calculated your displacement, then you apply the compatibility equation. This is the compatibility equation when your DOI equal to 1. When your DOI equal to 1, it means you have one unknown, and that's why here they have one equation only. One equation to determine one unknown. Okay. Delta 1 means displacement at D in X direction for actual structure. Delta 10 means displacement at D in X direction for primary structure, plus delta 11 means displacement at D in X when you refer to redundant number 1. Okay, so delta 10, you have the value actually. Okay, because what you have learned from the previous subject, determinate structure, because to determine this delta 10, delta 11, actually you apply the virtual work method for statically determinate, because primary and redundant structure, this is statically determinate. So you apply the virtual work method, which is how to calculate delta 10. It means this is equal to the summation of N1 multiplied by N0 multiplied by L divided by AE. N1 means this is internal forces for primary structure. Oh, sorry, internal forces for redundant number 1. N0 means internal forces for primary structure, which is we have calculated this value here, N0 and N1. N0 means for primary structure, N1 for redundant. Primary structure and redundant. So delta 10, because value delta 10 equal to 0. And delta 11 here, delta 11 here equal to 10 over AE. 10 over AE. 10 over AE. Okay, multiplied by R1. So this value you substitute into delta 10, because delta 10 equal to 0, and delta 11 equal to 10 over AE R1. You substitute here, so your compatibility equation become like this. This is represent the delta 10, and this is represent the delta 11. Okay, this is from your primary, this is from your redundant number 1. Why they have 800 over EA here? This is displacement at D in X direction for actual structure, because in your question clearly mentioned this problem, they have support movement at D in X. They have support movement 800 over EA clearly mentioned in your problem. So that's why on the actual structure they have 800 over EA. Then by now you substitute already all the values here, delta 1, delta 10, and delta 11, del 11 here. So this equation you can solve for R. EA you can cancel off, so R equal to 80 kilonewton. Okay, R equal to 80 kilonewton. You got the positive value. When you got the positive value, it means what is the R1? R1 means your redundant force. You have choose at the early session just now, we have choose your redundant force dx. So dx equal to 80 kilonewton. Positive means your dx follow the direction 1 kilonewton we have applied here. It means dx 80 kilonewton to the right. If this value negative, this value negative, it means 80 kilonewton to the left. Okay, after you have determined the redundant force, your next task to determine N. This N represent the internal forces for actual structure. What you have determined just now, R1, this is your redundant forces. Okay, redundant forces. So internal forces for actual structure equal to internal forces for primary structure, the value here, plus internal forces for redundant structure multiplied by R1. R1 means your redundant force just now. So N1 multiplied by R1 plus N0, you got this value. Okay, for example, how to get the minus 50? This N0 means minus 50, N1 0. So minus 50 plus 0 minus 50. Here because n0 and n1 0, that's why 0 here. For AD, n0 here 0, n1 equal to 1, 1 multiplied by 80, got the 80 here, similar to BC and CD. So this example, they ask you to determine the internal forces for indeterminate structure. So this is the answer. This is internal forces for indeterminate structure. Okay. Thank you. Assalamualaikum.